Hey there, Nick Jatakis here. In this video, we're going to go over how to shrink your Docker images by up to about 50%, or roughly cutting them in half. Now, this isn't going to be some weird clickbait where it's like, really? Up to 50%? Do you actually mean 1% most of the time? No, but of course your mileage is going to vary depending on your project. But I do have all these different Docker starter apps for Flask, Django, Rails, Node, and Phoenix. And in all 5 cases here, I was able to reduce my image size by about half, or roughly 50%, which is pretty nice here. And really it's going to come down to one common strategy that's going to apply to really any setup. You know, it doesn't necessarily need to be these web frameworks. And it's really going to be separating out your build time dependencies from your runtime dependencies, and then using Docker multi-stage builds to facilitate that, to make it really painless for you so that you can just run a Docker Compose build. All the things are just going to work, and then you're going to get a nice optimized image at the end. And the nice thing about this too is, the strategy is going to work independent of whatever base image that you have. So if you're using something like Debian Slim, which is what I like, it's going to work. If you're using Alpine, it's also going to work. So yeah, it really isn't so much project specific here. So the things we're going to go in this video, feel free to apply them back to your project. Let us know how it goes in the comments below. But before we're doing some, before and afters on the Dockerfile, which we are going to do, we're going to take a look at them for all the different web frameworks here. We're going to really go into one detail for the Flask one, and then kind of just see how it applies to the other ones as well. I think it would be a good idea to kind of just differentiate what is a build time dependency versus a runtime dependency before we actually jump into some real code. But I do think we should look at some code while describing even the differences between that, just to make it a little bit easier to understand what's going on. So here is a Flask application, and here is a list of dependencies in a Pi project Dockerfile. And if you're using something like Rails, maybe this would be your gem file that you can bundle install, or it could be a package.json file if you're using Node, or maybe in Python if you're using pip, then it could be a requirements.txt file. In this case, I'm actually using UV, which is pretty interesting. I'm going to definitely make a video about that one in the future. But in any case here, okay, we have got a list of dependencies for this project. And when you do a Docker Compose build, all these Python packages need to be installed. Or if you're in a Rails app, you would bundle install them, etc., etc. And in your Dockerfile, typically you would, copy in, let's say this file here, do your pip install or UV install, whatever it happens to be. And then after that, you would copy in all of your application code, then run your server, and then you would be good to go. That takes advantage of using Docker's layer caching there, just to make it so that when you update your application code, but not your dependencies, then things will be nice and quick when building things. But to even get to the point where you can install all of these packages, then you need to set up your system for that to work. Now, in this case, air quote system would be your Docker image, right? Things that you have set up in your Docker file. And actually, maybe it would make sense to maybe just walk through very basic level, a very Docker file without using multi-stage builds. So let me go ahead and just check out an earlier commit here, which is going to be, I guess, before multi-stage build. So let's just use the latest one here. I'm going to go and check this one out. Now we can actually take a look here at the Dockerfile, and this is technically using multi-stage builds for assets. I've covered that years ago in a DockerCon talk in 2021. I'll link a card for that one if you want to go and check it out. But in this case, we have one single stage here for the Python Dockerfile, and then it goes all the way to running the Unicorn, which is the application server in the end. But yeah, just to get those packages installed that we just saw in that other file, right, the Pi project Atomo file, we need to, first apt install a whole bunch of different things, because some of these dependencies, for example, going back to here, a lot of these are written in Python, but some of them require C dependencies to be installed. For example, psycopg is a really popular, really great Postgres adapter, and it has some C dependencies. Now, with Python, there's these things called wheels, and other package managers have the same concept here, but if one of your packages requires having binaries created, like for example for C dependencies, or it needs to be compiled or whatever, it's possible that the package author will already upload these files for you with the correct operating system and CPU architecture. So with that said, if you're running this on a Linux system, let's say in Docker, on a Debian-based system there, and you have, like an AMD 64 CPU, then if the binary could already be created by the package author, so you don't actually need to compile anything. But if that combination for your system isn't available, then your system will need to install it. Now, typically package managers help you in this regard here. You don't really need to think about it too much. But yeah, maybe you've run in the past, maybe a pip install or a bundle install at Rails or whatever, and now you've got some weird error that comes up, and it's like missing C header file, and then you go off Googling for the error, and then you finally apt install some system package to make that work. So yeah, if we go back to this Dockerfile here, it's pretty common to, like, for example, here's the one for psycopg. It's like you would need to install libpq-dev, which is a package. And again, if you're using Alpine, the package names are going to be a little bit different, but the same exact concept applies here. But to get around this issue of compiling C dependencies and libraries and some other stuff, Build Essential is a really good package to put in. And if we take a look here real quick at Build Essential, we don't need to go into all the details of what this is, but it's essentially like a meta package in the idea that it's a package that contains other packages. So, you can kind of click through all these things and see all the different stuff that's being installed. You can see, like tar and make, and, there's some C compilers and some other things that are here. And this is really helpful for compiling C libraries and stuff. Like, you don't need to think about all these things because, this thing pulls in all the stuff for you. But that comes at a cost, right? There is roughly 250 megs of files here. And if your image size is 500 megs, that means half of it basically is Build Essential. So if you can set up your Dockerfile to not need Build Essential at runtime, then suddenly, your 500 megs goes to about 250, and then you've cut your image in half here with some pretty painless strategies here as well. So that's how basically that comes together. And, if we're going to be doing some before and after, let's look at the before, right? In this case, we have one single stage here, and we have Build Essential because we need it. I like having curl. It's just really nice to debug things. And then also, we need this for PsychoPG, which is the Postgres adapter. That could be PG with Rails instead. It's a very similar concept there. And there's a lot of stuff in this Dockerfile that I've done in previous videos that are unrelated to this concept here. We're setting up like a non-root user. I didn't do any videos about UV yet. Absolutely will. It's an awesome tool. But the things that really matter here, it's like, okay, so first we're just copying in our PyProject Atama file and lock file. This is pretty common, has nothing to do with multi-stage builds, right? But typically you would copy in that one file first, and then you would run your install command for your package manager, right? This could be your pip install, UV install, bundle install, yarn install, whatever it happens to be. I've got the UV one tucked away in a little shell script, not important for the sake of this video here. But then once all your dependencies are installed, then you would copy in your application code here, do whatever you need to do, blah, 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 blah. And then eventually you would start your web application. In this case, this is just an application server Unicorn with Python. If you're using Puma with Rails, something is comparable there. And then that's it, right? It's like now you've got your Docker image all set up, all your dependencies are there, all your files are there, you can start your process and you're good to go. But this is going to produce, an image that's over 500 megs in size because your image is going to contain Build Essential and some other stuff as well. So you can actually use multi-stage builds now to maybe only do this in one stage, get rid of it, and then just copy over the end result to what you need, and then you're good to go. That's basically how things go. So when it comes to build time dependencies or, build time, just thinking about build time dependencies, that's what I'm talking about. So it's like, this type of thing. And then we also have, all of our package dependencies that actually get installed when you run your package manager. But then on the flip side, you have things like runtime dependencies, which is really like, what do you actually need for Unicorn, in this case, if we go back to the Dockerfile, to start? Like, you don't need UV installed technically. You don't need to compile C dependencies. Basically just files need to exist in a certain location with the correct user permissions, and then you're good to go and things are going to start. So if I go back to here and maybe, what can we do here? We can go to branches, and then, I'm just going to check out the main branch here, which, by the way, all this code is available on GitHub. I'll leave a link to all that in the description here. But here we actually have multiple stages going on here. Here we have, one stage, and then down here we also have the next stage, or actually should have said up here we have the first build stage, and then down here we have the actual application stage. But some core differences, I guess, between the before and after what we just saw versus now is, now we have this being labeled with a stage app build, and then down here we have another stage which is just app. But if we take a look here at the build stage, it's pretty similar to what we just saw in the before, but it's also going to be doing a little bit less. So in this case, still installing Build Essential, still installing curl, libpqdev, etc., still copying in the lock file and regular PyProject Atama file, just like we did before. But then it's going to be doing a UV install. In this case, it could be a pip install or, bundle install, etc., as we mentioned before. But here it's like, well, it's not even going to bother running the application because really, like, who cares? Like, we're just building our dependencies and putting them in a certain location. Now, one takeaway here that's really important is when it comes to using UV at least, and this is going to also apply to other package managers and languages as well, like, we need to kind of sort of configure where these files are going to get installed to. So with UV, there is this one environment variable that you can set where it's like, we're going to put everything in the .local directory for whatever user is running these commands. Now, in this case, I do have things set up. So I am, creating a Python user. So in home Python, that's where all the files are going to be. This is where all the Python package dependencies are going to be installed to. That's an important thing to be aware of because we're going to have to like find that out in the other build stage and then basically copy from that. But in that case, it's like, yep, okay, cool. All of our Python packages are here. Everything is installed. Everything is nice in this directory here. But yeah, in here, notice that we are still installing packages in this stage, right? We're installing curl and libpqdev. Build essential is not there. That's the important takeaway there on how we're saving so much space because this stage does not need build essential. Now, it technically doesn't need curl. I just like to keep curl around at runtime because it's useful for debugging stuff. And, sometimes I just want to make a curl request for my container. I find that is pretty useful in production once in a while. libpqdev is an interesting one because, we just spent like a long time explaining how build time versus runtime dependencies work. But this is actually sort of a runtime dependency as well, at least for psychopg. For example, if you were to get rid of this in this stage and try to run it, then yeah, psychopg is going to throw an exception saying that it can't find, some certain C file, et cetera, et cetera. Apparently, certain libraries will need certain things at runtime. I guess a takeaway is, and I was going to maybe talk about this one at the end, but one takeaway is after you build your image, you'll want to make sure that you can actually still run it. That's a really important thing because just because it builds successfully doesn't mean it's going to run successfully. I guess that's a takeaway there. So in that case, yeah, we still include it here just to make things work. It's not super huge. I think it was like 12 megs or something like that, which I guess in the grand scheme of things, if your image is 250 megs in size, then yeah, your 12 megs is, it's kind of a lot, but it's like not too much. But yeah, maybe there's a more efficient way to optimize that by just like picking out the exact file that it needs, but I don't really mind installing it there. Then it's like, okay, well, we're still going to set up, a Python user here because we want to run Gunicorn as a non-root user, of course. But we're also, configuring UV also here in the same way, saying like, hey, by the way, this is where all the files are going to be. But instead of actually running the UV install script or a pip install or bundle install, notice that that is not over here. So if we scroll back up here, we have this one line, which is basically running our UV install. That line doesn't exist down here. Instead, all of that just gets replaced by this. So we have one copy line here, which we're just going to copy the files in as a Python user. Here is the really important part. And again, in that DockerCon talk, I went into more detail about how multi-stage builds work. But in this case, we're just saying from, which basically says, hey, by the way, Docker, I want to copy this from a different stage. And here we have the stage as app build. Why? Because we jump back all the way up here. Then yeah, the name of this, well, this one over here is called app build. And of course, you can name these whatever you want, as long as it adheres to Docker's policies on naming conventions there. But in this case, it's like, okay, what do we want to do then? Yep, we want to copy it from, here is the source, from the actual stage app build. There's the file path there. And then to, which is going to be in this stage that we're currently in right now, which is the app stage. So yeah, it's very similar to like the copy command on the command line in Linux without Docker, right? It's going to take in a source, going to take in a destination. In this case, they happen to be the same because, yeah, we have this Python user created in both of them. And at that point, it's like sort of kind of done. Like, okay, because think about it from this perspective. The Python runtime, it doesn't really care that you compile things or have these packages installed in a certain way. Like, it's just like, hey, cool, like this is where all the files are. I understand this is where the Python files that you asked for are located. I got it. I understand. I'm going to go and run it. And then Gunicorn is like, totally got it. That's where the Python environment is. So this is really nice. And then also, separate to that, unrelated kind of to this video, I like to also just copy in UV itself, the tool, the package manager tool. Technically, this isn't needed, but yeah, I just use this to detect like outdated dependencies and, maybe update some lock files really quickly. So that's a super quick rundown on multi-stage builds, but then you might be wondering like, well, how do you actually like reference a stage or something? Like, how do I even build a thing when it's a multi-stage build? So if we take a look here at the compose file here, up top, this is a pretty, tricked out Docker compose file. But the real takeaway here is in your service, you can have a build namespace here, a property, and then we'll just say the context for the current directory because that's where the Dockerfile is. Then this is really the line that's important, which is the target. So in this case, the target is going to be app. Again, the DockerCon video goes into more details about that. But yeah, if we go back to the Dockerfile here, that lines up exactly what the stage name here is. So its app is going to match, if we go to the compose file here, yeah, this app over here. So if that were named different, then you would want to name this line different as well. from there, Docker it's smart enough to know that, okay, well, you've got this one app stage as the target. Yeah, but you need to get stuff from this previous stage. So Docker is going to be like, oh, understood. I'm going to go and look at this, do all the building. And like, you don't even need to think about it as a developer there. And of course, if you wanted to like specifically target this stage in your build instead, you can totally go back to your compose.yaml file and then just change that stage up here to be app-build. And then that would get build. And of course, that image is going to be bigger. It's also not going to run Unicorn because you can see here in this case too, I'm not even copying in the application code here. It's also just running bash just because that's what I prefer. Again, you could technically run and copy your code into the stage if you wanted to, but since we're not really like running it, then it's not really that important in my opinion. But again, it's up to you. You can absolutely do it. It's not going to like break if you don't do it or something like that. But yeah, that's really it. But now you might be thinking like, well, that's cool. Like, how can I apply that to other web frameworks? And yeah, I mean, we're going to spend a lot less time on the other examples, but I just wanted to show you, in detail one example, and then you can apply it to the others. But yeah, like the Django setup here, if we go, and again, this is like essentially the same thing because, Django is just a different web framework using Python. So the patterns here are the same, right? It's again, app build, there's build essential, there's UV, same thing, copying in this, blah, 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 blah. Here's a second stage. There's our copying in from the other stage of where we did literally the same thing actually. And then if we go to the compose file as well, it's all the same thing here, target app, etc. Then for Rails, if we go and take a look here, let's go to the Dockerfile for Rails. Then yeah, sort of similar, slightly different, but kind of same concept. So in this case, there is really only one stage here for the app because we also have this asset stage here. And, Rails does some really nice things around, pre-compiling assets and some other things that requires access to your JavaScript and CSS. So, I'm kind of like loading up this asset stage as being both something that runs all the asset related things like Tailwind and ES build, which by the way, the Django and Flask examples, they also have that too, for example, up here. But yeah, the Rails one also deals with bundle installing in the stage too. So all of our build dependencies are just rolled up into this asset stage. Here you can see build essential, there's libpq dev, there's another one for YAML, etc. Things that are just necessary to get everything to work on systems here. But then when we have the app stage here, you can see here, there's no build essential, there's no anything else that we don't need. There's libpq dev again, and there's curl again. But it's using the same patterns here. So if we go back to up here, it's like, before we copied in that UV lock file, if we go back to over here, let me go down to here, you can see, this line here, right? We're copying in the PyProject.toml and the UV lock. Well, for Rails, we're copying the gem file and the gem file lock, just using the starred pattern here because check it out on the sidebar, there's our gem file. And then we also have the lock file right there next to it, very similar file name. So you can just use star to copy them both in a way that works. Even if your gem file lock file doesn't exist, this pattern will still work, which is pretty nice here. Then we're also kind of doing the same thing here for Yarn because we also have a package.json, which also was handled in that other stage there, not important, but general takeaway is, yep, there's our, file and the lock file, and then we're doing a bundle install instead of a UV install. And then, yeah, okay. So now let's go back to the other stage for the app. Then it's like, yeah, that's just not there. But instead, what are we doing? Well, we're just copying in where things got installed too. So in this case here, we have user local bundle. That is a location where all of our gems are going to be installed to. So going back to the Flask application example here, it was being installed to home Python local in this example application, but for Rails, they're just being installed here. And we are setting things up where we do have a Ruby user as well. But yeah, it's just a different location, but exact same concept. Exactly the same. And then we're copying in things. We're doing a Rails S that's going to run Puma under the hood, and then you're good to go. So that's exactly how you can do it in Rails. And again, I saved about 250 megs, roughly 50%. Maybe it was like 40, like 3% or something in the Rails app. It was pretty comparable there. Pretty nice to have. And then yeah, for Node, again, all same stuff that we were just chatting about before. So if we go to the Dockerfile here, then, here's our asset stage, whatever. Then we have our app build stage. This one's more comparable to the setup with Flask and Django. We can see build essential here, blah, 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 blah. Here we're copying in the backend dependencies here because this also has this idea of like a backend and a front end with a Node app, whatever. But we're still doing our yarn install here in the stage there, just running, our bash command there. And then, yeah, for the app stage, same thing. No build essential here, right? And then in this case, I do have Node module set up a directory here in the root directory. This has been configured with a, where is this at? I don't know, but I think it's the yarn.rc file or something like this. Yeah, there it is. So here it is. The modules folder is node modules. I've actually done more details about this in this DockerCon video on that pattern here. But long story short, this is where all the node modules are installed to. It's in the root of the file system in the image here because we don't want to, volume mount it out, whatever. I don't want to get into all that in this video here, but that's why it's there. But the general takeaway is, yeah, we're just copying from that stage to the node modules here, and Yarn is already configured to read from there. So it's like everything is just going to work in the same way it did for Flask, in the same way it did for Django, in the same way it did for Rails. And then, of course, we're just running our Yarn command here, which is going to run the application server there. It happens to be using Express here. Cool. Okay. Phoenix 1, slightly different, but pretty much the same, just a little bit extra steps. So here we have a Dockerfile. We also have an asset stage here too. Then we also have different names for the stages here. I chose dev as a one stage here and prod as a different stage here. And we'll see why in a second, just because, Elixir and Phoenix are a little bit different than the others, but exact same stuff is going on here. For example, in our dev stage, you can think about this one as, if you're doing like a Docker Compose app in development or building or whatever, there is our build essential and some other tools that are required as well. Cool, that's nice. But then in production, and I should mention here too that, there's a lot going on in this file, but long story short, it's doing a mix install somewhere in here where, this is all Elixir related stuff. Essentially, instead of doing a bundle install or UV, blah, 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 or pip install, this is just mix. That's the package manager tooling name here in Elixir's world. Yeah, we copy in our app, we run our server, etc. Everything was there. But in the production one, it's a little bit different. So in this case, yeah, what we have is the same pattern as before, where we're just copying in files from a different stage. In this case, it's from dev. And this is where everything is located for Elixir to run a release. I don't want to get into the details of that one, but yeah, there's this concept of making a release, which is essentially just all the files that you need for your application to run. There's no build time dependencies there as well. And then, yeah, you can just run the release, and that's a whole other topic in its own. But again, it is an example of, showing off how this pattern works in a completely different type of way to run things just by leveraging multi-stage builds. There's kind of a lot going on there, I suppose, but at the same time, it doesn't really complicate things that much. Like, yes, you do need to know about a new concept around multi-stage builds, but it's not making the builds really any slower that's perceivable. It's also not doing some crazy low-level tweaking or workflow changes. These are all standard Docker tools to get you going. And then hopefully in the end, you'll save a couple hundred megs in your Dockerfile, which is going to save some, storage costs or network transfer costs or anything like that, which is always pretty nice. It's also going to save some space, in CI servers, caches, and all good things basically. So with that said, if you have any questions, let me know in the comments below. I'll do my best to answer all of them. If you like the video, please give a thumbs up. It really does help a lot. Thanks a lot for watching, and I'll see you in the next video.